Hello, everybody. Welcome to the presentation that I wanted to share with you today, which is entitled Riding the Second Wave, Open Source for Relational Databases. And as we've got quite a bit of content, let's dive directly in. So who am I to be here today to speak to you? Just a very brief background. Name is Jan Karremans, active on Twitter. You can find the handle here. I've got a little bit of history in databases in IT, even more than I would care to remember. So I'm just going to glance over that. You can read this for yourself. I am an Oracle ACE alumni. When I migrated myself from Oracle to Postgres, I got elevated from regular ACE to alumni. In other words, they kicked me out of the program. And meanwhile, I am a certified EDB Postgres Advanced Server professional. I actually work for Enterprise DB. Enterprise DB, as you might know, the leader in the Postgres community, especially with the recent acquisition of Second Quadrant. I think EDB is now very well equipped to help customers embrace Postgres, adopt Postgres really in an enterprise grade, and actually start moving away from traditional proprietary database systems to cool open source and open systems. And what I wanted to talk about a little bit here is what it actually means to engage with open source. Actually, where did it come from? How did it evolve, etc., and talk a little bit about that. Thinking about open source, I kind of distinguish two waves, if you like, of open source. And the first one is, and perhaps you might not have realized that, but it's quite old already. Open source started more or less at the same point where we were able to distinguish software from hardware, to separate those two out. As soon as we were able to build a computer that could run a program, and you could load another program, that is actually when open source already started, because that was the first instance where people were able to kind of build a program, share it with somebody, and actually get more people to use that software. The very first initiative in this case was Share, and Share dates back as far as 1955. So that means, to do a quick arithmetic, 65 years of open source in that sense. Deakus might be another very familiar brand or name for some of you that have looked a little bit in open source. Deakus was part of Digital Equipment Corporation, followed quickly by GNU, and these last years, obviously, last years is nearly 30 years ago, with Linux. These are technologies I would classify as the first wave of open source, and I will explain in a little bit why. Some of you might remember this character. His name is Richard Stallman. Richard Stallman is the embodiment of open source, if you like. Open source, free as in freedom. Richard wanted to make a change. He wanted to break the locks, and in research for this presentation, I even found that there is an open source song that you could sing and that you could adopt. But all it was about is like, we want to make a change. If you have closed source solutions, and again, this is no value statement about open source versus closed source, but it's very much, how can we get the most out of the computer infrastructure that we have? How can we get the most out of the solutions that we're working with? How can we get these to fit the best to our business needs? And because that is what it always boils down to, is how does the solution fit your business needs? trying to make a change here. Richard Stallman, again, as the embodiment, as the driver. There is this very famous picture of Richard where he's in the lane separation of a freeway, I guess it was, with the sign "free" as in freedom, fighting for his ideas in the world for open source software. Why would we then kind of classify this first wave? What are some of the characteristics? When open source started, it was talking about the easier to replace systems. I'm not saying they were simple systems, but they were easy to replace in a business context. So if you, for instance, look at editors or other utilities, if you look at an operating system, from a business perspective, if you're using an editor, it is fairly easy to say, you know, I've been using this editor today to work on my scripts and to work on my text files. And, you know, it's a little bit quirky. It doesn't really fit in how I want to work. I'm going to try another editor, right? So I'm going to stop using this one. I'm going to take another editor, and that might have a few of these features and a few of these tools that make it easier for me to handle. Same, for instance, goes for application servers, right? An application server runs a specific program that's written in a language. If you have another application server that supports that same language, for the sake of argument, let's say Java, if we've got another Java-based application server, chances are I can fairly easy replace that system with another web server that actually fits better to what I needed to do, that perhaps has a better execution of a specific issue that I've built in my program, that perhaps has a better performance, or it fits better in the specific use case that I want to achieve while running my application. Goes to say, easier to replace. This was the first wave of software that rolled, and you can identify that by, you know, at some point where that first wave stopped and became more of a serve, was like, okay, Linux is fully adopted and we're in kind of more or less stable situation from that respect. And then we come to the second wave, because if you've got a first wave, there is bound to be a second wave, right? The second wave classifies a lot more complex systems, right? They're not so easy to replace. That's an essence for something. Why would that be important for software? If you as a company want to invest in a system, you're going to do that for a longer term. So you need stability. You need to be able to trust the software, right? Because it's going to be a significant business risk that we're seeing. There is a lot of value going around with the implementation of this software. So this is something where you want to be sure. We've seen in that second wave of software of open source adoption that the inherent trust in open source is a lot bigger, because we've had this first wave. We've all had the discussion like, do I want to run my business on an open source operating system? Is that really something I dare to do or not? And well, yes, businesses have adopted Linux in an overwhelming fashion. So the inherent trust in open source is there. And that also means that this second wave has a ground for starting to roll over the IT world in essence. Just a couple of words on open source versus closed source software. And as I've said earlier in this presentation and in many other presentations as well, it's not a value statement, but in many cases, having an open source system makes a lot of sense. If it's general purpose software, having an open source solution makes good sense, because there is an increasing group of people that can actually help. There is an increasing group of people that can help support and build out the system, share the system, and add value to it. This is a very important thing, because that way you can kind of diversify the input, you can diversify the amount of people that start thinking about the software, and actually add a lot more value and a lot more usability to the software in a much quicker time. So this is one of the things in a closed software solution. That's obviously, if it's a very niche approach, if you have to have very deep specific knowledge, it might make sense to build software in a closed source solution, just simply because there are a lot of people that can help support that. But you have a dedicated group of developers working on this who can actually 100% dedicate their time to that. So that is a little bit the differentiation in that sense. Some of you might have seen Mr. Bruce Momjan's presentation, Will Postgres Live Forever? For those people, this is going to be a rehearsal. They will have seen this before. But I just wanted to highlight the life cycles of proprietary software versus open source software. Proprietary software starts with innovation, starts with market growth. You will see a lot of investment capital behind these solutions, because, you know, they've seen a chance to build software and to make a lot of money. They will put a lot of effort in building, they will put a lot of effort in marketing, they will put a lot of selling effort in it, they will have great success, and this product will take off in that sense. But at some point there will be market saturation, right? There is nothing where you can start adding something to the software that will help increase adoption, because if everybody's running your software, who would you want to sell to? So then you come into a situation, and we see this with a lot of software solutions out there. We see that in traditional relational database. So we are a relational database company, so we look at that a little bit, you know. If you look at IBM's DB2, if you look at Oracle, if you look at Microsoft SQL Server, increasing shareholder value, that's what it's about, is looking at different ways of doing things. Not in innovation in the database, because you're not going to sell any more database licenses, because everybody who you were ever going to sell to has bought your software, right? So you get more or less in maintenance mode, and as what we've seen, there are companies out there that actually buy these kind of end-of-life solutions. It will start to die out, and other solutions will take over. If you compare this life cycle to how open source software will actually, and I apologize for the mistake in the slide. If you look at the adoption of open source software, what you will see is that you will get to parity with proprietary software, because the drive to start building software is bigger. There are people that are trying to solve problems. They're trying to solve their own day-to-day problems and actually contribute to software. As Bruce made the comparison, it's like ancient philosopher ideas. As long as these ideas stay alive, people will continue to use them. The same is with software like Postgres, for instance, in this case. As long as Postgres is relevant, people will continue to use, innovate, and build on Postgres. At some point where, you know, there is not that drive anymore, so you will get into the same kind of, you know, Postgres was cool 20 years ago, not today anymore. I'm not saying that it is, because, you know, practice proves the other side. But saying that, you could always say, you know, If it starts to decline, at least the source code is always available for you as an entity. If you've invested in Postgres, Postgres will always be there. So that's the big difference between proprietary and open source software in that sense. Here also the Metcalfes Law applies. As long as more people work on the open source solution, the more powerful it will get, right? Because as more people start using Postgres, in this case, more people will start thinking about Postgres, will start contributing to Postgres and start helping Postgres to grow. So this is Metcalfes Law applying here and actually helping drive Postgres to bigger growth. And that's what we see in kind of the adoption of open source. So this is a graph pulled from dbengines.com that kind of show the growth of open source. Still today, it's continuing, and we predict that it will continue to grow. And if you look at a snapshot, this is November 2020. This is now. If you look at open source licenses, support licenses versus commercial licenses, we already see that more people are actually starting to adopt open source software in general, and Postgres is an important part of that. So now we've seen wave 1 and wave 2, and we actually see these waves coming crashing together, right? What can we start doing if we see all of these things in open source come together? What are some of the characteristics? And I was actually wanting to make a list of open source projects that could be of interest for this talk, right? And I started doing that, and oh my God, I just felt like I was falling in a pool and drowning. Just looking at libraries.io, 4.4 million open source packages across 37 different package managers, and it was still not a complete list. So if you look at that, and if you really focus on databases, we're database people, so let's focus on databases within that list, then this is just a very short grasp of some of the brands that are in there. Greenplum, Firebird DB. Truth is, I didn't even know it existed before I joined EDB, but it's an open source database, but also NoSQL databases, etc. And very importantly, in the center, always Postgres. This is just databases. If we would look at in the spirit of the IT landscape management, where does open source play in? And I just looked at application build to application deployment, CI/CD, and all of these things that are happening today, actually up until IT management. These are all projects touching each and every part of an IT operation landscape today that are open source build, open source developed, etc. So that you can run your entire IT environment on open source, and I would bet $1 that most of you guys are doing that today. Another thing, and I just talked about that briefly, is this paradigm shift in application development. We used to start doing waterfall development, right? There was this project, and we started to build, and we did build, we did test, we did implementation, and then we started a new cycle. This was a very good idea if you want to start building larger monolithic applications that from a traditional perspective actually added value. If you went to the application landscape of those days, today that's changing, right? We're wanting to get away from these big monolithic applications, and we want to get into something that fits today's paradigm of I need to be able to change quickly. I need to be able to get new features. I need to be able to get new things in my environment quicker. But if you would use the traditional mindset, you would end up with something like this. And if I've seen the beluga fly, because I had the good fortune of working in Hamburg, and my office actually looked out on the fly-in route of the Airbus factory in Hamburg. So I saw it come over, and oh my God, is the thing ugly, right? It does the trick, but it's ugly to see. It does the work, but it's not what you want. In an agile application environment, you want something like this. Small granules that together kind of make these gracious forms in the sky. This is the IT infrastructure, the application landscape that we're actually moving to together. It even starts more looking like this, these kind of neural networks. If you look at things like AI coming, if you look at things like agile application development, microservices, an application, a website, a web application is broken up in very small functions, very small increments of, and all of these increments have a complete own management system. This is not something we can do in an agile or in a waterfall model, I'm sorry. So we need to actually build something that fits that. This is a nice overview of the complexity today that you would need in a microservices implementation, and all of the various bits and pieces that you kind of need to drive and to build out. In that context, relational as in relational databases is more relevant than ever. The need for data processing, but it keeps on growing. We have all of these NoSQL databases, all of this kind of new way of getting data, harvesting data. But if you need to analyze data, SQL will never die. And I often kind of look back at this kind of, at this picture. It's the genealogy of relational databases. And as you see today, the sheer number of relational database solutions has grown tremendously, right? SQL will never die. If you look at Postgres and where actually Postgres plays the biggest part, is systems of analysis. Most of our customers use Postgres for system of analysis. That means data analysis, data warehousing, data marks, and systems of a record as a second good one. These are the more traditional ways of using a relational database. But it goes to show that if you want to use and work with data, you need a relational database system, right? And you might think, you know, I have everything under control. My system is running, data ingest is something that I can work with, but hey, reality might sometimes be different, right? You get blown away by the humongous amounts of data that's actually coming into your organization that you need to capture, that you need to process, that you need to work with. And we see that happening in, you know, big data was a word. It's a little bit from the past already, but big data didn't necessarily mean more data. It was a description of how that data was built up, that you needed to analyze it. But big data leads to more data. If you look at some of the other graphs on how fast data is growing today, IDC predicted by this year, so the graph is dated with that, obviously, that we would have reached 40 zettabytes of data. These are unfathomable numbers of data or sizes of data that we're actually dealing with on a day-to-day basis. We see a lot of proliferation in where data comes from, in how we store data, in how we process data. We've seen the NoSQL solutions, right? Where we thought, you know, SQL has always been a big problem. Let's just move to NoSQL and most of my problems will go away. Thing is, SQL is the way to actually make sense of data. Structuring data afterwards is super expensive, right? So if you can have a solution that does both, and Postgres is one of those solutions that does unstructured data and structured data together in this one data engine, data processing engine, if you like. So this could be a very good way forward to actually adopt SQL and still be able to play with the bigger amounts of data that kind of keep coming to us. And remember, and this is something I've said before, there was this tweet by Mongo that said, real friends don't let real friends use relational databases. Well, they're wrong. Even 1974, Ted Cott versus Charlie Bachman in something called The Great Debate, just had a debate on relational versus non-relational versus hierarchical databases. And surprise, surprise, relational databases won. Relational databases were built to solve some of the NoSQL hierarchical database problems. So actually, real friends encourage real friends to use relational databases. So everything we've seen in nearly the past half hour, what does that actually mean? So if you look from a business perspective, open source helps to reduce dependencies. Hence, you gain flexibility. We've seen the IT infrastructure landscape, how it was built up from open source solutions, and how that helps companies to kind of find their own way and kind of positioning solutions. It helps to reduce costs, right? Because free as in freedom, there is no such thing as a free lunch, and we have all these kind of cool sayings with free in it, but it will still have a cost tied to it, but you will be able to reduce cost by just adopting this open source solution and actually giving back and or working with companies like EDB to fill that position back to the community for you. From an operations perspective, and let me be clear, this is in no way, shape or form meant as a conclusive list, right? From an operations perspective, why open source? Well, mix and match. There is no silver bullet in this is the solution that will solve all your problems. There is no such thing. It will give you the ability to mix and match a bunch of these solutions, find exactly what fits the best with your organization, and actually build the IT management infrastructure that fits your operation the best. And it will help you adhere to standards, right? Because if you look at Postgres, the implementation of the SQL ANSI standard is one of the more purer in Postgres than to other solutions out there. And finally, on the development perspective, you get the ability to focus on opportunities and not on limitations. If the tool doesn't do what you want it to do, you can actually go out and change the tool, help the tool to do what it needs you to do. And if you find enough people that actually support your idea and your stance in that, you will get other people to help build. And if not, you can do it yourself, extend and expand at your own leisure, right? So this is a very important step forward in software development. So with that, in the last 30 minutes, I hope I gave you a little bit of an insight into what I think is open source wave 1 and wave 2 and some of the pros and cons there. Thank you very much.